Everyone. So today in this video we are going to look at the O-level additional mathematics. Okay, so for the chapter about the function. So first of all we are going to look at the mapping. Okay, what is the mapping actually? So mapping is a rule, okay, which connect the input here and the output. What is exactly the mapping? Okay, so in this text we have a definition of the mapping. The mapping is the rule connecting the input and output, okay, values. Can be written algebraically like that. So here is the mapping, the definition of mapping, the rule that connecting the input and output values. So for mapping we should have the input values and also the output values. Okay, so sometimes we can write it algebraically as like this. Okay, so we will read it as the x is mapped to x plus 1. Okay, when we talk about the mapping we use the arrow like this. Okay, so don't use this arrow. This arrow is not correct, so use this arrow. There is a tail here. Okay, use this. Okay, so I use this arrow. So if I write it like this, x, so we read it as x is mapped to x squared. Okay, or we can use the k sine x or sine k. So we can read it as the k is mapped to sine k degree. Okay, so okay, now we look at the next text. Okay, so the mapping can be represented graphically by plotting the values of x plus 1 against value of x plus 1. So we have two ways. Okay, from this we have two ways to talk about the map, to represent the mapping. Okay, we can represent the mapping algebraically and graphically. Okay, so by algebraically we just write it like this. Okay, use this arrow, and graphically we can draw a graph like this. Okay, so to draw a graph, okay, we will see later on. Okay, so the diagram shows for one input values there is just one output value. It is called the one-to-one mapping. Okay, that means from this diagram, okay, if I take one value of x, therefore there is one value of y here. Okay, so that means this relation of mapping is one-to-one. Okay, so here is the three relations that you should know. Okay, so firstly is one-to-one. Okay, one-to-one is the for one input value there is just one output value. So if you substitute there is x, will give you a value of x plus 1. all right, so the value of x plus 1 must be unique. Okay, so we have also many to one relation. Okay, so it means that for two input values there is one output values. That means two input values, let's say this one is x1 and x2. Okay, and then here it can be x1 squared and it can be x2 squared. So that means we have x1 is actually not equals to x2, but x1 squared can be equals to x2 squared. But from this one-to-one, okay, let's say this one is x2 and this one is x1. Okay, so if I say that x1 is not equals to x2, that means that it means that This one is x2 plus 1, and x1 plus 1 and x2 plus 1. It will give you that x1 plus 1 is not equals to x2 plus 1. It satisfies the definition of the one-to-one relation. How about one-many? For one-to-many, okay, we have here is x1, okay, and let's say you have also x2. Oh no, there is no need. Okay, so x1, let's say you have x1, okay, so if you put this into this function, you will get square root x1 plus or minus, and at the same time it can be two value, which is plus square root x1 or minus square root x1. It can be two value. So when one value is substituted into the relation, there are two values in this relation. So this relation is called as the one-to-many. Substitute one will give you many solution, and for many-to-one, you substitute too many value into this relation, you will get one solution only. And one-to-one, when you substitute one value only, and you will get one only. So remember, when you substitute one value, you will get one value for one-to-one. But for many-to-one, you substitute too many value at the same time, it will give you the same value. Okay, and for one-to-many, you substitute one value, you can get many value of solution. All right, so that is about the mapping. Let's see the exercise 1.1. Determine whether each of these mappings is one-to-one, many-to-one, or one-to-many. So number one is x is mapped into x plus 1, where x is a real number. So how to define this? So let's say we have the number of x1 and x2, which is not the same. So if I substitute into this relation, we will get x1 plus 1, which is, and also I substitute x2 into this relation, we will get x2 plus 1. Therefore we get this definition, this equation, okay, in equation that it satisfies the definition of one-to-one. So x is mapped onto x plus 1 is a one-to-one relation. One-to-one relation. Alright, so number 2, okay, number 2, let's say I substitute x1 into this, you will get x1 squared plus 5. And first of all, you should say that x1 is not equals to x2. Alright, so when you substitute into this x squared, you will get x1 squared equals to x2 squared. It can be same value. Alright, when you add 5 both sides, you will get x1 squared plus 5 equals to x2 squared plus 5. But this definition is not always correct. Alright, it is many-to-one. Sometimes x1 squared is not equal to x2 squared. Sometimes. Okay, to check it one-to-one or not, okay, so let's say we just draw a graph. Okay, so just draw a graph here. So the graph of this function, this relation must be like this. This 5 So if I put -1 here and 1, okay, the value of -1 squared plus 5 is actually 6. If I put the x1 into this equation, okay, I will get the same value. If we put the -1 squared plus 5 here, we will get 6. If I put 1 squared plus 5, you will get the same value. So you get -1 squared plus 5 is actually equals to 1 squared plus 5. They give you the same value. It means that two values give the same value, which is one value. That means that this relation is many to one relation. Okay, many value mapped into the one value. So this one is the many to one relation. So I hope you understand for this video. Thank you for watching.